In this video, we will show you how easy it is to generate forest plots with e-Campsis to visualize the impact of covariates. For a proper forest plot with confidence intervals, you will need to import a non-mem model with a successful covariance step. A message below the parameter tables will show if the variance covariance matrix was properly loaded from the .cov file. Next, you set up the study design from which you will derive the variables of interest. As you will see in a moment, you will be able to use practically any derived variable for a forest plot, including design-sensitive NCA parameters, like half-life or Cmax, so be sure to choose appropriate sampling times. Go to the simulation screen to check that the profile looks as intended. On the post-processing screen, you can define the outcome variables that you want to show in the forest plots. Check out our previous video on post-processing where we explained the functionality in detail. Not only can you use any parameter as coded in the model, such as clearance or volume, but as mentioned earlier, you can use derived variables such as Cmax, AUC, half-life, and even pharmacodynamic endpoints, like maximum receptor occupancy as in our example. Once you have defined your output variables, you can go to the forest plot screen. Select the study arm and the output variables on the left-hand side. In the box on the right, you define the covariate labels, units, and the reference or default value. For continuous covariates, you have to enter the upper and lower values to simulate, for example, the 5th and 95th percentile of its distribution. For a categorical covariate, you would enter the levels. Next, choose the number of forest plot items, and pick the covariate value to be shown in the item. You can also make combinations of covariate values. Now you are ready to go. The confidence intervals in a forest plot will be generated by replicate simulations with random sampling from the variance covariance matrix. Since this process is quite computationally intensive and may take a while, we suggest you only run a few replicates online. If you are satisfied with the results, you can then download the automatically generated R code and re-execute the simulation with more replicates offline. Some annotation options are available to adjust the axis limits and breaks as well as the reference range. Now you can click through the plots and explore the impact of covariates on the different endpoints. On the download screen, the complete R code is available for download and offline execution. Here you can easily increase the number of replicates as you like. Visit e-Campsis.com to check out the free version or request a trial of e-Campsis Pro.